Hello, this is Tony Nichols, co-founder and Chief Technical Officer of Great Ideas. And in our enterprise architecture, with examples using Microsoft.NET Blazor, Azure, Great Ideas Trellis Spark, we're now going to consider the overview to the technical architecture tutorials that will follow later in this course. So the purpose of this particular video is to give you an introduction into the scope and what we mean by technical architecture. And although my primary focus over the last 4 decades has been application development, it's also been very important to me as an application developer to understand the technology on which we're deploying our applications. So one thing that we need to consider here are the different sorts of hybrid architectures that are available now, some of the key security considerations, building highly available systems, understanding how to get the best performance and scalability out of our applications and data, what to back up, how to back it up, also understanding the difference between disaster recovery and business continuity planning. So as ever, this video will give us an overview of what the topic contains, and then we'll be doing a set of deep dive videos into each of these topics. So first and foremost, let's think about hybrid architecture and what we mean by that. So if we were considering what technical architecture was when I started 40 odd years ago, essentially we'd be looking at electrical engineering diagrams, circuit diagrams, chipset descriptions and things like that. We'd be building circuit boards and putting them into very large physical racks. The state of architecture at the moment from a technology side has truly changed and is constantly accelerating. So now we're not just considering building room-sized computers, we need to consider lots of different things. So for example, even in the location of where we're going to deploy our server infrastructure. Some of our infrastructure may be on-premise in corporate data centers. Some of the information may be stored inside public cloud. Some of the infrastructure may even be on private clouds in public data centers. So the locations on which we deploy our infrastructure have exploded over the last decade. Also, what we've seen is a vast increase in the deployment methods. So whereas before we were actually building physical hardware, we went into virtualization. And now when we're looking at cloud services, we're looking at 3 main types of cloud service. The idea of infrastructure as a service, where you're buying storage or virtual machines onside a virtual network. So you're actually building out infrastructure components that as an organization, you will still be responsible for managing and patching, through to platform as a service, where instead of building out VMs for web servers, I would just say, well, I need to be able to deploy a web application within a cloud provider. Right the way through to, well, instead of building an HR system or a CRM system, I want to use a software as a service or a SaaS app, like, for example, Microsoft Dynamics or ServiceNow or Salesforce.com, for example. So the methods in which we deploy from a location perspective, the methods that we deploy in terms of what are we actually deploying, have radically changed over the last couple of decades. And increasingly what we're seeing is an explosion of essentially cloud services. So things this is like Power BI for dashboards, data lakes, the idea of the metaverse, the idea of all of these massive services that are being deployed through our public clouds that are available for us to pick up and use and adopt in our solutions as just nebulous. There's this service out there in the cloud that we can now bring that functionality into our applications. So we're seeing a huge change in architecture. We're seeing a huge change in how we need to think about architecture. And this hybrid architecture approach is now a core aspect of the technical architecture, but also from an application development perspective, it's something we need to understand in some level of detail so that we are not just constantly rebuilding things that we can actually get very cheaply from a very high quality provider. So as we've mentioned multiple times in other videos, one of the key aspects that we need to be thinking about whenever we architect something is security. So the GDPR framework that was released by the European Union a few years ago essentially is giving a whole bunch of considerations around security and privacy of information. And while a lot of those considerations are related to essentially business architecture, business processes, and things that people need to do in terms of capturing information and making sure that information isn't shared beyond where it's needed, there's a whole bunch of technology considerations that we need to incorporate as well. One of those things is really understanding that we need to be building everything to be secure by design. And one of the best ways of approaching that is using a standards-based framework that we can then say, well, okay, we have built this framework. I'm going to deploy this application, this service within the context of this framework. And because I already have considered in the framework design all of the related security standards, models, processes, and practices, I can then just apply those as a block to the new service. And that way, I'm not missing something. I've not created a gap or a hole in my security infrastructure. So one of the key things with architectural frameworks is to make sure that you have a standards-based framework that applies security consistently across all of our applications. One of the other things that we need to do within our frameworks is have a clear separation of concern. So the sorts of technology standards that we're going to apply to, say, data at rest are different from those as they're being applied to data presentation or data in motion. So one of the things that we want to identify in our framework is what are we doing with data? Are we presenting it to a user? Are we using it as part of workflow? Are we storing it? Are we transforming it and moving it around? So understanding the separation of concerns in terms of how we're acting with our technology, what we're trying to protect, and then making sure that that's part of our standards-based framework and that we're applying the appropriate architectural principles in each of those areas of concern to build what we would describe as an overlapping defense in depth. We want to make really sure that whatever we're doing, we have protected ourselves, we have covered ourselves in multiple different ways with multiple different standards to make it as hard as possible for hackers to get into our system. And to a certain extent, that means understanding modern identity management, multi-factor authentications, and then how does all that identity management interact with our technology, interact with our data, and make sure that the individual users only have access to the data they actually need. So, for example, if I am the Tony user, I don't necessarily need access to all of the customer records. I may need access to a subset of those customer records. How do I guarantee that Tony can access those records that he actually needs access to? And this basically involves technology, it involves data architecture, and it also involves the application architecture as well. So all of these things come into play, and we need to make sure that we're considering this as part of building our defense in depth solution. A key aspect that we're going to also consider as security considerations is the idea of firewalls and intrusion detection and prevention. So what mechanisms can we employ to make sure that people coming in to actually access the data are using trusted identities through trusted connections and accessing data appropriately? And then when we're looking at information coming in, how are we going to use antivirus, malware detection and things like that to make sure that the information coming into the system is not actually bringing in a threat to the environment? And then overarching all of this is our monitoring, alerting, our software incident management techniques. So we're going to be doing a set of videos essentially on all of these topics. Each of these is going to spawn its own in-depth video. Another key consideration for our technology is the availability of the solutions that we're providing. So one thing that we're going to be looking at is the idea of high availability. And availability is normally scheduled in terms of how many nines do you want? Do you want 99.9% availability or 99.99% availability and so on? 100% availability, you're never going to get. So what we're going to be looking at when we look at high availability from a technical perspective is how do we look at the availability of things like, say, data storage. So if we're talking about physical storage, RAID disk arrays, what are the options there? Or evolution into things like storage area networks or SANs, cloud storage options and so on. So we'll be doing some videos around data storage, what the different mechanisms are, when they're appropriate, how to actually use them, how to secure them, how to make sure that they're part of your overall enterprise technical architecture. Related to storage, obviously we have database options, so things like relational or no document databases. What are the options for ensuring the availability of databases? So we'll be looking at things like clustered service options. Microsoft have this idea of an always-on availability group. We're going to be looking at cloud service provision and so on. So we'll be looking at a number of videos related to how do we ensure the availability of a database and record storage. We'll also need to consider, obviously, workflow. So if we're going to have web servers, can we load balance those web servers so that if a single web server fails, that the load balancer is going to redistribute the load across the surviving servers? How does that work, for example, when we're looking at cloud services, so PaaS solutions and SaaS applications and so on? So again, a whole bunch of different videos related to how do we ensure that our technology is highly available? How do we design our applications to take advantage of high availability solution options? The next thing we need to consider from a technical perspective is performance and scalability. So to a certain extent, this is the last level where we can actually influence performance and scalability. Ideally, we want to make sure that our data storage, our data architecture and our application architecture is fully optimized for performance and scalability. So there are a whole bunch of considerations that will take place in our coding and our data structures and our indexing and so on. But the bottom of the stack is technology. And there we're going to be looking at, well, how do we understand the factors in our technology that are actually creating bottlenecks in our performance and scalability of the solutions as a whole, and how can we then optimize the performance and scalability of the stack at the end of the day? And we're going to be looking at two different types of scaling methodology. So vertical scaling, so essentially it's maybe adding more memory, more CPU, more disk IOPS to servers, and also horizontal scaling options. So how can we add more servers into a pool to actually deliver the performance that we need? So there are a number of technological aspects to this design from an architectural perspective, but those actually are providing a base layer, a foundation for decisions that are ultimately going to be made in our application and data layers. Next, we need to understand the things that we actually need to back up in our system. So when people talk about backups, the first thing they think about is databases. When did we do the database backup? And sounds easy, okay? But if you say got an enterprise that's got 100 databases that are sharing information, and you're trying to do backup and restore of hundreds of databases, then you've got like a database consistency issue to sort of think about, right? So, when you've got like 100 databases sharing, say, customer information, and it's moving data from database A to database B, and you've done your backups, and database A backup was at 11 o'clock and database B backup was at 1 o'clock in the morning, then if you need to restore from those last full backups, how do you ensure that you actually have consistency between the databases? So one of the things we're going to be talking about in a video is some of the issues related to database backups and integrity of information across large enterprises. Next thing people think about from a backup perspective is file storage. So while most of the time we're sure and we understand how to back up a file server, sometimes these personal devices that people are using, our laptops, our desktops, are not actually part of a scheduled backup process or not actually backed up correctly. And this can be a problem, especially when people are using a lot of feral or shadow IT, where they're using spreadsheets or access databases that are on their local desktops and actually have relevant business information in, but that desktop then gets lost, and then we remember that they didn't back up their personal files this week. Again, that can be a huge problem. So we'll be looking at some file storage backup solutions and things like that to consider as well. One thing that an IT team generally tends to think about is email backups. So you've got all of your mailboxes and you've got thousands of emails in your mailboxes, and it's a good idea to have that backed up as well. But as we move to cloud storage and we're using like Office 365, not a lot of people are thinking about backing up that Office 365 email storage. That's something else that we should be considering too. Cloud storage in general, so it's fairly obvious that if I've got file storage on my on-premise, I need to be doing some backup. But if I've got, say, cloud storage in Microsoft Azure or AWS, do I still need to back that up? And the answer is probably yes. You should actually have a copy of that cloud storage backed up somewhere else as well. We talked about file storage and backing up file storage from personal devices and servers, but we also need to be able to back up the servers and devices themselves, because those servers, they have an operating system on them, they have applications on them, they have configuration information on them and so on. So it's a good idea to image our servers and devices on a regular basis. So if we lose something or it breaks, then we can actually recover from an image. So again, one of the things that we'll be considering around things to back up is server and device backups. Another aspect related to that, as we just touched on, was this idea of configuration. And it's not always obvious what we mean, right? So for example, if we're thinking about configuration, let's say you have a firewall. Okay, and you've basically got a firewall, you set up a ton of firewall rules. Did you back the rules up? If that firewall breaks and you have to replace the device, can you restore the configuration from a backup from somewhere? So when we're thinking about things to back up, we should also be thinking about things that where we've put configuration into things, and it may be configuration of cloud services. It'd be a good idea if we also make sure that all of that configuration information is backed up too. And then finally, as an application developer, I'm always thinking about my source code, right? So I want to make sure that all of my software, all of my code repositories are also backed up so that I can recover in the case that a server is lost or my desktop fails. I want to be able to go back to my source code repositories and bring it back from the repo, but I should also make sure that I'm backing up the source code repository, right? Because the last thing I want is for my repository vendor to lose my repository, and then I've lost all of the versions of all of my code with all of its DevOps history. So some things to think about when we're looking at backups. We're going to need to think about encryption. So obviously, if we're going to back up a database, it would be a good idea if the backup of the database was also encrypted. We're going to need to talk about data consistency on restore. So in the scenarios where I've got hundreds of applications and hundreds of databases, if I'm restoring from backup because of an issue with a data center and I need to recover it to a secondary location, how do I make sure that when I do my restore, I'm actually getting some sort of consistent view of the data across all of those databases? Related to this is this idea of off-site, right? There's no point doing a backup if you leave the backup on site and then the site burns down, right? Because then you lost your primary data and you lost your backups. So this is almost a table stakes. When you're doing backups, you want to make sure that you copy the backups off-site as soon as possible. And if you're doing disaster recovery, then ideally those off-site backups would be copied to the disaster recovery site as well. One thing to think about with backups is that we want them scheduled on a regular basis, and we want appropriate monitoring of those backups to make sure that they happen and that they're at least reporting that they were completed successfully. And then every now and again, we also need to test the recovery and restore process to make sure that the backups that we're creating on a regular basis can actually be restored, and the restore process into a secondary location actually works, and we get a consistent restore of the database or the file system that we've recovered. One thing to be especially careful of, okay, is that from an IT perspective, we're generally very good at backing up the formal IT, the databases that we know about, the file shares that we know about. But the other thing that we have to remember is that increasingly business users are reverting to shadow or feral IT solutions, where they're basically building their own systems as workarounds where we're failing to support them with our applications as part of formal IT. So we've seen organizations where the backup shadow feral IT can account for 60 to 80% of what's actually going on in the business. We were working with an organization recently where probably 80 to 90% of the actual operation of the business was taking place using feral IT in spreadsheets rather than using the primary IT systems that the business thought were in use. So those systems were so out of date or were so unable to support the business that the majority of the business functionality had resorted to spreadsheets. And the question then becomes is, are all of those spreadsheets actually even known by the formal IT organization, and are they being properly backed up? So this problem with shadow and feral IT is a huge problem when it comes to backing up and making sure that critical business data is actually in locations that can be retrieved and covered. This is particularly true when you have business users who are using private Dropboxes or private cloud storage solutions to maintain their own backups of this information. What happens when that person leaves the organization? The backups in their personal Dropbox are now no longer available to the organization. And that, again, is a huge problem. So all of these considerations as they relate to backups are things that we need to consider as part of our backup strategy and overall architectures. So we talked about high availability in a previous slide. I have the issue where, let's say, for example, I have a database cluster. I have two servers, a master server and a passive server. And in the case where the master server fails, it will fail over to the backup server, the secondary server, and operation will resume. That's basically high availability. Failure of a single server doesn't compromise the solution as a whole. It just fails over to a secondary server. And that's our high availability design. Our disaster recovery design is for when things go badly wrong. So it's not the failure of a server within a data center, it's losing the whole data center. Let's say, for example, we have an office building, there's 100 people in the office, there's a server room in the office, all of the servers and all of the people, we're all using a common network within the office, all of the backups are in the office, and then the office burns down. So from that perspective, right, the office has gone, the data center has gone, all of the data has gone, all of my backups of the data have gone. It's a catastrophic failure for the business. So what we consider with disaster recovery is this is the worst case scenario. Wherever you are storing that data in that data center is no longer available. It's burnt down, it's in an area where there's a huge power cut, it was hit by a meteorite, whatever, okay? It's no longer there. So one thing that a lot of businesses do now is that they are considering the idea of IT disaster recovery. And essentially this comes down to the idea of a primary and a secondary data center. So a primary data center is where the business is operating out of on a normal day-to-day basis, and all of the information and applications that are available from the primary data center are being mirrored in a secondary data center. Now, ideally, that secondary data center is geographically separated by at least 300 kilometers from the primary data center. So if there is a massive power failure, if there is a fire, if there is something that basically is a regional disaster that's taking this primary data center out of circulation, ideally the secondary data center is so far away that it can actually recover operations and be unaffected by that regional issue. When we consider the design of primary and secondary data centers, then there are three basic considerations that we need to look at, whether it's a hot data center, so failure of primary immediately falls over to secondary with no data loss, no time loss. Warm, where that cutover may take hours or maybe a day or two, or cold, where we've reserved a secondary data center, but we still need to bring up the servers, the infrastructures, restore backups, and so on. So essentially, when we're considering the design of primary and secondary data centers, we need to decide whether we want hot, warm, or cold secondary data centers. And obviously, there is an increasing cost. Hot data centers are a lot more expensive and difficult to set up than cold data centers. So one of the things that we need to consider when we're looking at disaster recovery is what are our key requirements? And this is at a solution or in an environment level. So the DR requirements for a development environment are going to be very different from those of a production environment. Now, even saying the production environment, you don't necessarily mean everything that's inside the production environment. There might be some applications which are absolutely business critical that have to be restored quickly into the secondary data center. And even in the production environment, there may be some applications which are secondary, tertiary functions that don't have to be flipped over as quickly into the secondary environment. Maybe I can wait a day or two or a week before I bring those secondary systems up. So essentially, for each solution, each environment, I need to answer two basic questions. What's my recovery time objective? So how quickly must I be able to restore operation in the secondary location? And what's my recovery point objective? How much data can I afford to lose when I switch over from primary to secondary? So we're going to be doing a whole bunch of videos around disaster recovery design and architecture, some of the considerations, some of the costs that we need to consider. And when we look at disaster recovery, we need to consider two key processes. We need to consider the failover process. So at what point do we initiate failover from primary to secondary? What's the criteria? How much of that data center must be missing? Loss of a single server, you know what, don't care. The high availability should deal with it. Loss of all of the web servers now, okay, if that really happened, do I cut over to secondary? Loss of the whole data center, well, that's obviously a no-brainer. I cut over to secondary. So from a failover perspective, what triggers failover? And then if I am going to failover, what's my plan for failover? How is it going to work? Who is going to do it? How do we bring the systems up? What order do we bring the systems up in? And then the other thing that we need to consider as a key process is how do we fail back? So we failed from primary to secondary. We've conducted normal operations in secondary for a while, and then maybe our primary data center has come back online. So how do I take the data out of my secondary data center and revert control back to my primary data center? So those are two key processes, failover and recovery. And we're also going to look, obviously, at some of the key technologies related to that. One of the most important, obviously, being backups. So how do we actually transfer data from primary to secondary? But there's also a whole bunch of other technologies that we might need to consider as well as part of that disaster recovery solution. Now, a related topic to disaster recovery that sometimes people get confused about is this idea of a business continuity plan, or BCP. And essentially, a business continuity plan is what is the business doing when we're having one of these disasters, right? So this is more about how does the business respond to a major incident. And it could be the response because we've lost the data center, or it could be the data center was within an office and we've lost the whole office. So now we've got to deal with not just the fact that we're going to need to move our data center from our primary to our secondary location, but where are the 300 employees that used to sit in this office now going to sit so they can actually use that data? So essentially, what we're considering with business continuity planning is a bigger picture of disaster recovery, which may or may not include the failure of a data center. So for example, the data center could be in the cloud and we could have just had the office burned down, right? So we could still have, okay, I've got 300 people that used to sit in a network computer inside Office A. Office A is no longer available. Where do I put those 300 people? Are they working from home? Do I have to distribute them across 3 other sites and set up network connections so they can connect to our data center and continue operations? So when we're considering business continuity planning, it may or may not include disaster recovery from a failed data center. So from a business continuity plan, again, we're talking about a communication plan. We need to understand how does the business declare a failure? How does it notify all of the business units that there have been a failure? And then how do we actually initiate the actual failover from a business perspective? The failover planning as part of business continuity planning is we now need to notify all of these people that we need to do something differently. One thing that's slightly different between the DR and the BCP is that we really need to consider reduced operations. So if I'm failing over from A to B, from primary to secondary, I may also be dealing with reduced operations. So as we said earlier, when we're considering the DR planning, is that there may be 100 applications in my organization and maybe 30 of them are considered critical and they are going to fail over first. And then the other 70 come back over the period of a couple of weeks maybe. So one thing that we need to consider as part of our business continuity plan is reduced operations from a business perspective. So if there are certain applications that are not going to be available, then what do we do when we have business processes that are using those functions that are no longer available? We've got some sort of manual process that we're recording the fact that we need to do this thing. And then when that application becomes available, we're going to be able to actually then go through a manual recovery process to work through that. So understanding we've failed from A to B, we didn't bring everything up in B. What are the reduced operations from a business perspective? How do we record the fact that we've gone into this process and this is the work that needs to be caught up when the new applications become available? And then finally, once we are ready to recover back to our primary sites or we are moving into a new normal mode, what does recovery look like? How do we catch up on everything that was in the reduced operation cycles? And how do we bring all of this stuff back? So as you can imagine, right, this is like a huge topic in and of itself. So we'll be doing a couple of videos related to business continuity planning as an extension to what we're looking at for disaster recovery planning. So as you can appreciate, technical architecture is a huge subject. It's something that's continuously changing as a landscape. It's probably one of the fastest growing areas that we need to consider from an enterprise architecture perspective, particularly with the proliferation of cloud solutions, new deployment options and methodologies, new security threats and mechanisms for preventing hackers getting into our systems. And we will be doing a bunch of videos that will work in detail through all of these different aspects of technical architecture and how they relate to the development and deployment of applications and data that will enable us to properly support our businesses.
To learn more about Great Ideas products and solutions, visit greatideas.com. That's great ideas with a Z.com. Thanks.